Okay, for lesson P4, we're going to be talking about the coordinate plane again, but in terms of equations and graphs of lines. So we're going to focus on a couple of things first. The first concept we're going to deal with is the slope of a line. Okay? And then we're also going to talk about some different forms of equations for lines. Okay? So let's start with talking about slope. When we have a line in the coordinate plane, okay, that goes through a couple of points. These are two arbitrary points, notice. Keep in mind with the notation in here, when I have x with a little 1 and a little 1 with a y, okay, that just means our first x and first y. Okay, that subscript is just telling us, just differentiates between the 2 points. When we label this point, notice it's x2, y2. Those are going to be, that's going to be just our second point. So second x, second y. All right. And what it boils down to is that when we talk about a slope for this line, okay, the slope for this line is going to be how far does the line go up as we move to the right. Okay, we've all heard in the past the phrase rise over run. Okay. And that's essentially what we're after here when we describe the slope of this line. We want to know how high does it go, okay, as we go a certain amount to the right. Okay, so that's going to be our rise over our run. Now, I want you to notice the notation on here, this triangle notation that we use. That's the Greek letter delta. Okay, all that Greek letter means is the change in. Okay, so when we see that delta x, that just means the change in x or the change in y. Okay, so as I go from this point to this point on the coordinate plane, how much did my y change and how much did my x change? Okay, and what it boils down to is that the division of those two elements is the slope. Okay? That's the rise over the run. It's delta y over delta x. Okay? Change in y over change in x. Okay? So what that does for us is using these 2 points as our arbitrary points, we can write an equation for the slope of any line. And of course that slope formula looks the same as it has since we learned it in algebra. Okay? Y2 minus y1 divided by x2 minus x1. Okay, so if we have any 2 points on the coordinate plane, we can find the slope between them by finding that exact part, change in y over change in x. Okay, just as an aside, usually I see mistakes on this concept because people put the x's on top and the y's on the bottom. So we got to be careful that we follow the formula and have the y's on top, x's on the bottom. That's usually the most common mistake. The other common mistake that I see is that people mess up the negative sign here. Okay? So if I have certain points that have negatives in there, okay, sometimes we get messed up with subtracting negatives, etc. Okay, so we got to make sure we're careful by putting things in parentheses, which I'll show you in just a minute. Okay? Another point here is that if the line is vertical, okay, the slope is undefined. Okay? And if you think about it, if I had 2 points that were vertical to each other, like say 2, 3, and 2, 7, okay, if I did 7 minus 3 and 2 minus 2, what would that give me on the bottom? I'd have 0 on the bottom of the fraction, which is undefined. True? So we say that if the line is vertical, the slope is undefined. Would it be okay to have, let's say, 2, 5 and 3, 5? If I had that, those 2 points, if I graphed them maybe horizontal to each other, and I'd have 5 minus 5, 3 minus 2, I'd give 0 over 1. And remember that 0 on top is okay. The answer is simply 0. So a horizontal line is going to have a slope of 0. Okay? So make sure we're careful about where the 0 is. If it's on the bottom, we have problems. If it's on the top, it's fine. It's just 0, and that's it. All right, let's take a look at an example here. They give us 2 points that are neither parallel, or neither horizontal or vertical, I should say. So let's go ahead and if you need to, one thing that you could do if you need it is to actually put your own labels on these points so that you know which point goes where in the slope formula. Okay. So when I write my m equals, my y2 is 1, and when I go minus, I'm going to put negative 2 in parentheses. Okay. Any number I put in here, I would put in parentheses that's negative. You don't have to put it in parentheses, but I would get in the habit of doing that just so you can keep your sign straight. And then of course on the bottom we have 0 minus 3. So again, if you plug in any negative numbers, Okay, put them in there in parentheses and make sure that you're careful with your signs. So like I said, that's the most common error, is that people don't use parentheses or put the signs in incorrectly, and then that leads to mistakes. Okay. So with that said, we'd have 1 minus minus becomes a plus. So we'd have a 3 on top. 0 minus 3 is negative 3. And of course, just like any fraction, we'll reduce it. And in this particular case, turns out to be a whole number, negative 1. Okay. Okay. And just to clarify also, what is that telling us about these 2 points, or the line that contains these 2 points? If we were to graph these two, 3, negative 2 is right here. 0, 1 we know is right here. If we were to look at the graph of the line that connects those two, okay, what that negative 1 is indicating, first of all, since it's negative, it means the line is going down as we go from left to right. It's one fact. Okay, it also tells us how it's going down. Okay, if we were to rewrite this in the rise over run form, any whole number, of course, can be written with a 1 underneath it. So that means that we're going to rise negative 1, run 1. So if we rise negative 1, which way would that indicate to get from any point to any other point? Rise negative means go down 1, and we'll always run to the right. And you'll notice if I do that, rise 1 negative, and then run 1, we get to that point. If we do that again, rise negative 1, run 1, rise negative 1, run 1. Okay, and notice that every time I do that, I end up back on the line, don't I? Okay, so that slope indicates how we're moving from left to right. Okay, are we going up or are we going down? And then ultimately, how steep is it? Because if this would have been negative 5, then this line would have been a whole lot steeper, because I would have gone down 5 and over 1, down 5 and over 1, and it would have been much steeper too. Okay. Any questions about slope so far? Okay. All right. At this